50. The pH of normal urine is 6.30, and the total phosphate concentration, which is PO4 3 minus plus HPO4 2 minus plus H2PO4 minus plus H3PO4 is 0.020 molarity. What is the minimum concentration of calcium, 2 plus, necessary to induce kidney stone formation? And then see exercise 15.49 for additional information. Okay, so basically the additional information that we needed was that kidney stone formation, 50% of it comes from the ionic compound calcium phosphate, which is Ca3PO4 So when we're trying to find out that minimum concentration of calcium, we have to take it from this compound, the Ca3PO4. Now, I did also go in the back of the textbook to find out what that KSP value is, right? But if you notice, calcium phosphate is divvied up between just the calcium and just the PO4. Now, the only thing that we know is that the combination of all of these phosphates is equal to 0.020. Somehow, I have to make some type of algebraic expression in which I can basically get rid of these because I only need the one that just is the PO4, and that's this guy. But how do I do that? Well, they gave us the pH of normal urine. Now, this is going back to the last chapter, right? What can I do with the pH value? Well, remember, from a pH, you could always find the H plus concentration. So that's the first thing we're going to do. So I'm just going to bring this out. And let's just actually do it on the side here. So I'm going to say that H plus is equal to 10 to the negative pH. They told us that that pH was 6.30. So I'm just going to do that into the calculator and see what I get. So H plus equals 10 to the negative 6.3. So 10 to the negative 6.3. So I get 5.0119. Now I don't want to cut it off too short for sig figs. Times 10 to the negative 7th. Okay. All right, so now we have a H plus molarity. Well, if we're dealing with pH values, right, and they gave us all of these phosphates, and 3 out of the 4 of them have an acidic hydrogen in the front, we could basically use our Ka values. So what I'm going to do is I'm just going to get rid of this. I'm going to drop this down because the list is getting shorter and shorter of things that we need to do. Now, I did have to go to the back of the textbook to get all the Ka values of each individual acid. So 7.5 times 10 to the negative third is H3PO4's Ka value. 6.2 times 10 to the negative 8th is H2PO4 minuses. And then 4.2 times 10 to the negative 13th is HPO4 2 minuses. Okay, now somehow we have to basically use these formulas that are with the Ka value to maybe just get a PO4. So let's work from the bottom up, right? The first acid that we can deal with is HPO4 because that's only one hydrogen away from just the PO4. So let's write out that balanced equation. So I have HPO4 minus, and remember, these are aqueous, right? And acids are great because you can just dissociate it into its H and the rest of it. And this should be a negative 2. Okay, so then we have H plus PO4 3 minus. They're both charges, so they're aqueous. Okay? And we have the H plus concentration. So that goes over here. So 5.0119 times 10 to the negative 7th. And this is what we're solving for. So I don't know what that is. So we could label it as X. But for now, what I'm going to do is, since we're going to try to just get everything in terms of phosphate, keep in mind that's the only one we want. I'm just going to leave it as just the concentration of the phosphate. And then this would just be the concentration of HPO4, 2-. Because technically we don't know that either, right? We know that the sum of all 4 of these is 0.020, but I don't know what that specific concentration is. Now, let's write our Ka expression. Remember, Ka is products divided by reactants. So Ka, in this case, would equal the concentration of H+, that's the hydronium, times the concentration of PO4, 3-, divided by the concentration of the HPO4. Okay. Well, we know the Ka value for this one. It's the last one written. So 4.2 times 10 to the negative 13th. And we know that the H plus is 5.0119 times 10 to the negative 7th. But we don't know what these two are. But remember, you kind of want to solve for your phosphate. So what I'm going to do is I'm just going to manipulate this equation so that I can get it equal to my phosphate. So let's see. I'm going to say 4.2 times 10 to the negative 13th equals 5.0119 times 10 to the negative 17th times the concentration of the PO4, 3-, all divided by the concentration of the HPO4. Okay, because those two I don't know. Well, if we just cross multiply, right, and maybe I could just skip a couple of steps, I'm going to just skip, swap these two. So this number comes down here, and this goes up here, because that's essentially what we're doing. Okay, so let's just divide these two numbers. So HPO4, 2- equals, let's see what that number is, 5.0119 times 10 to the negative 7th divided by 4.2 times 10 to the negative 13th. And we get a pretty big number. Okay, now remember, whatever number you get, just trust the process. So you have 1.19, I guess we'll say 1.193 times 10 to the 1, 2, 3, 4, 5, 6. Okay, and that is times the concentration of the phosphate. Okie dokie. So this is where we're at. We can't really do much more math here because I don't know what the specific HPO4 2- concentration is, and I don't know what the phosphate one is. So this is another answer that we just need, and I'm going to just bring this over to the side. Now we're finished with this Ka value, so I could just put a check here. Now let's keep working our way up. Let's now write the Ka expression for H2PO4. So I'm just going to kind of rearrange this, right? So let's see, if I just get rid of this and I say, okay, this was H2PO4, that's a -1. And remember, you can only dissociate into one H. So what would be left over? It would be the HPO4, right? And this would now be a 2-. Well, let's erase these and put the numbers that we know. Keep in mind that, remember, the H plus is always going to be this number. So that has to stay. But now the HPO4 2-, did we find out a value for that? Oh, I can substitute this in. So my HPO4 2- is really 1.193 times 10 to the negative 6 times the phosphate ion concentration. You see how we're keeping this one in there because we need to, because that's the one we need to find out. So now all I'm going to do is I'm just going to change this, right? this is now going to be the H. PO4, 2 minus, and this is now H2. I'm just going to get rid of this because we're going to have a new one. And this is 1.193 times 10 to the negative 6 times that phosphate ion. And this is just going to stay itself because I don't know what that value is. So we'll just keep it as that. Okay, now let's just write it up and see what's happening. Actually, nope. Did anybody catch that? It is not 4.2 times 10 to the negative 13th anymore because we're using the second one. So this is now 6.2 times 10 to the negative 8th. Okay, so 6.2 times 10 to the negative 8th equals the 5.0119, that's the H plus concentration, times 1.193 times 10 to the negative 6, and that's times the phosphate ion concentration. And this is all divided by the H2PO4. Okay, now we do it the same, just like we did before, right? If we're cross-multiplying, ultimately you're just swapping these two values. So that's exactly what I'm going to do again. So this one comes up here, and this one comes down here. And now before I do anything, right, I just want to say that this should have been 10 to the 6th. So let's just fix that before we do the actual math. Thank God I caught that. Because now we're going to be multiplying these two together and then divide it by this, right? Okay, so now let's get that number. H2PO4 minus is, okay, here we go. 5.0119 times 10 to the negative 7 times 1.193 times 10 to the 6th divided by 6.2 times 10 to the negative 8th. I get another big number, but trust the process. We'll say 9.644 times 10 to the 1, 2, 3, 4, 5, 6. And then that's just times by the PO4 3 minus concentration. Okay, here is another solution that I'm going to use for later. And just, pay attention that we still have the PO4 in the game, which is what we want, right? We just want that PO4. Okay, so let's just bring this up. I'm just going to erase this just so that I could fit it. So just, pause the video if you just need any of these values. But there we go. Okay. And now we're done with the second one. We got one more Ka value to do. So let's go back to the top. Let's make a new equation. So instead of H2PO4, it's just going to be H3PO4. Remember, you could only get rid of one H at a time, and how many would be left over? 2 of them. So now this turns into H2PO4, and that's just a negative charge. Well, the H plus is the same, right? That doesn't change. And this is now going to be just the concentration of H3PO4. Now the H2 is what we just found out. So let's just erase this value. It is now 9.644 times 10 to the 6th times the phosphate ion concentration. Now let's just change our Ka value, right? Products. So this would be H2PO4, and that's just a negative charge. This would now be H3PO4. The H2 is the 9.644 times 10 to the 6th times the concentration of the phosphate. And we still don't know this, so that's going to be, staying there. And now we need to use the new Ka value, which is the 7.5. times 10 to the negative third. It's the first one. So pause the video if you need this, but this is going bye-bye because we need the new one. So it would be 7.5 times 10 to the negative third equals 5.0119 times 10 to the negative seventh times the 9.644 times 10 to the sixth, and that's the concentration of the phosphate. Okay. All divided by that H3PO4. Remember, we want to solve for what H3PO4 is in terms of the phosphate. So cross multiplication, aka we're just bringing this number down and this number up. Algebra purposes, we're just timesing these two numbers, and then we're dividing it by this number. So let's get the third value. H3PO4 is what of the PO4? 5.0119 times 10 to the negative seventh times 9.644 times 10 to the sixth divided by 7.5 times 10 to the negative 3. And now I just get like, maybe I'll 644.5 times the value of the phosphate PO4 3 minus. Okay. All right, we're on our way. This is the new value that we need. So I'm just going to drag that up. Beautiful. And as far as now all of our Ka values, we have done them all. So we have completed that part of this question. So I'm just going to erase the equations for Ka. We don't need them anymore. Pause the video if you do need to write this down, but I need to get rid of this because we have much more. We need room to do much more stuff. Okay. So now, here we go. Here's our 3 answers from before. And now we just need to make a ratio, right? Because remember, the total of these, 4 of them, equal 0.020 molarity. So let's just find out a ratio. What we're going to do is maybe we'll go from low to high. So we'll say, okay, PO4, 3 minus, to HPO4, 2 minus, to H2PO4, 1 minus, right? So just a negative, and then H3PO4. Now, in order to make these ratios, we have to make sure that we have a number for just the phosphate ion. Now, for every one of these, it seems like the higher H value is just some number times the phosphate, right? They're all times the phosphate. So you could make this phosphate number any number that you want. 1, 2, 3, 4, doesn't really matter. The easiest way to do it is to just make it a 1, right? So I'm just going to label that the phosphate ion for this ratio, it is not anything for the answer. Just for ratio purposes, it's just going to equal 1. So 1 goes with my phosphate. So now I'm just going to literally do the algebra, right? If we label the phosphate as 1, 1 times this value would equal the HPO4 2 minus. So 1 times this value is literally just that value. So 1.193 times 10 to the 6th goes with the HPO4. H2PO4 is 9.644 times 10 to the 6th times the phosphate. Since we said that the phosphate was equal to 1, 1 times this number is that number. So H2PO4 minus would be 9.644 times 10 to the 6th. And now we do it again. Since we labeled that the phosphate was equal to 1, H3PO4 is 644.5 times 1, which is that number. So 644.5. Okay. So now, if we want to find out what the ratio of the phosphate is, right, it's basically just a percentage. Now, we don't really have to times by 100 because we just want the fraction version, but it would be basically the amount of the phosphate PO4 3 minus divided by the total concentration, right? Brackets. And the total concentration is all of these added up. So what is that total fraction value? Well, let's see. 1 plus 1.193 times 10 to the 6th plus 9.644 times 10 to the 6th plus 644.5. I get a big number. I guess I'll say 1 point. We'll put it in scientific notation. 1.0838 times 10 to the 1, 2, 3, 4, 5, 6, 7. And that's the value that goes on the bottom. So the fraction form of the phosphate is 1 divided by the total, 1.0838 times 10 to the 7th. So it's going to be pretty small fraction form. So 1 divided by 1.0838 times 10 to the 7th. So I get roughly about 9.226, we'll say 8 times 10 to the negative 8th. So that's basically the fraction form of how much phosphate is in the total concentration. We can use this value to now figure out what is the actual concentration if the total is really 0.020 molarity. So what we could have done is we could have just put together just a ratio as well. But in essence, all we have to do now is just times by the total, 0.020, right? Because if we found out what fraction the phosphate is, I could just times it by what I have, which is the 0.020 molarity, and that would be the actual concentration of the phosphate. So PO4, 3 minus, actually equals 9.2268 times 10 to the negative 8th times 0.02. And there we go. A really low value, 1.845 times 10 to the negative 9th. And that's molarity. Oh, what's going on there? Oh my gosh, okay. Molarity. Okay. Now, did we answer the question? No. Right? What's the minimum concentration of calcium? But we are almost there because now we found out what that minimum concentration of phosphate is, right? So if we know the phosphate number now, we can find the calcium by using the KSP. So pause the video if you need it, but I'm going to just erase this because we need more room for the KSP. So bye-bye. We don't need this anymore. This is going bye-bye. Whoop. And I can kind of get rid of this. Beautiful. And this is basically what we need. Now, the KSP value was 1.3 times 10 to the negative 32. Let's just write out the KSP value for the Ca3 PO42, right? So Ca3 PO4 2, that's a solid. You're going to form the ions. So I have calcium. They told me it was 2+, so thank you for that. That's aqueous because it's a charge. And then the PO4, they told me it was 3-, so thank you. Aqueous. Let's just make sure that this is balanced. I need 3 calciums and 2 phosphates. I have 3 calciums and 2 phosphates. Now this value comes into play. The phosphate ion concentration is 1.845 times 10 to the negative 9th molarity. Don't fall into the trap that since we have a 2 here, I have to times this value by 2. This is the concentration for all of the phosphates that are in your solution. You just not miraculously have double this amount. Whatever value they give you, that's what you have to start with. And now we're solving for calcium, so I'm going to just label this as X, right? Now you can label this as 3X because there's a 3 in front. But when we do the math, we're always going to get X equals. If you label this as 3X, you're going to have to go back and times it by 3, your answer. And if you're pressed for time on an exam or a quiz, you might not have enough time to times it by 3. So me personally, for these types of questions, I just like to just keep it as X, because then whatever your answer is, it's X equals, that's the answer for your calcium. Okay, so now let's just write out the specific formula, right? KSP equals concentration of the calcium, 2+, times the concentration of the phosphate ion, PO4 3-, and then raise them to the coefficients. There was 3 calcium, so you have to raise that to the third. There was 2 phosphates, so you have to square that value. KSP is 1.3 times 10 to the negative 32. Calcium we're just going to label as X, and the phosphate we're going to label as 1.845 times 10 to the negative 9th. Let's just pull this up a little bit. And now let's do the actual math. So 1.3 times 10 to the negative 32nd equals, we have X cubed, and then 1.845 times 10 to the negative 9th. That's squared. So I guess we can square that first, right? So 1.845 times 10 to the negative 9th squared. This is the same, I'm just going to erase this. This is the same as 3.404 times 10 to the negative 18th. So now, just divide by that number. 3.404 times 10 to the negative 18th on both sides. 3.404 times 10 to the negative 18th on both sides. This cancels. And now we're left with the value, 1.3 times 10 to the negative 32 divided by 3.404 times 10 to the negative 18th. And I get 3.819 times 10 to the negative 15th. And this equals X cubed. Well, we can do the cube root on both sides, right? But just know that cube root just means that you're basically raising this to the inverse number. This was 3/1, so I could just raise this to the 1/3. And then these numbers will cancel out. 3 times 1/3 is just 1. And then that's essentially what you're doing on this side as well, raising it to the 1/3. So this goes bye-bye. And now you have X equals, so let's see, 3.819 times 10 to the negative 15th. I'm going to raise that to the 1/3. And I get 1.5. Technically, it should be 2 sig figs. So we'll say 1.6 times 10 to the negative 5th. And that's molarity. So now we wanted to find out that minimum concentration of calcium, Ca2+. We stated that it was just X. So it is 1.6 times 10 to the negative 5th molarity. And that is your final answer. Oh my goodness. This one was crazy, but I'm glad we went through it together. I hope this helped you out. What did you think? Let me know in the comments. A lot of different chapters coming in for this question, but if you can do this one, you got this chapter, all right? So keep studying hard, and I will talk to you in later lessons. Okay, bye-bye.